previous lesson, we were shown how we can sketch planes. Now, in this lesson, we will look at the way to sketch spheres and cylindrical surfaces. Okay, so at the end of this lesson, you must be able to sketch spheres as well as cylindrical surfaces. The equation x squared plus y squared plus z squared plus gx plus hy plus iz plus j equal to 0 in general would represent a sphere. However, there are occasions where this equation would be giving us a sphere, a point, or no graph at all. Okay, so let us investigate when this equation would give us a sphere, a point, or no graph at all. What we need to do is we transform this such that the terms in x, in y, and in z would be forming perfect squares. So we transform the equation to the sum of the squares of x minus x of 0, y minus y of 0, z minus z of 0, and that sum must be equal to some value k. Now, if k is positive, then the equation represents a sphere. But if k is 0, then the equation would represent a single point. Okay? And if k is negative, then the equation will have no graph. Because if we're going to transform the equation to this form, k there represent the square of the radius r. So, if we have this sphere here, the equation in the standard form would be given by the sum of the squares of x minus h, y minus k, and z minus l, and that sum must equal r squared. This would represent a circle or a sphere with center at HKL and radius of r. So to illustrate, let us consider describing the locus of the equation x squared plus y squared plus z squared plus 2x minus 4y minus 8z plus 5 equal to 0, and then sketch the curve. So what we do is, starting with this equation, what we do is we group the terms of the x's, the y's, and the z, and that we complete the squares of these groupings. So for x squared plus 2x to be a perfect square, we must have positive 1 as the third term. For y squared minus 4y, we must add 4 for it to be a perfect square. And for z minus 8z, we must add 16. So that z squared minus 8z plus 16 is a perfect square. Take note that we added 1, 4, and 16 on the left member of the equation. To retain the equality, we must also add 1, 4, and 16 to the right side. Okay? And this equation now is transformed to the sum of the square of x plus 1, the square of y minus 2, the square of z minus 4, and that sum is equal to 16. Having reduced the equation to this form, then this equation here will give us a sphere with center at -1, 2, 4 with radius of 4. Because k is positive, then the equation represents a sphere. So the sphere will look like this. Its center is at -1, 2, 4, and all the points that is lying on the surface of the sphere will be at a distance 4 from the center. So from the point -1 to 4, if you move along the horizontal parallel to the y-axis, then you hit this point which is on the surface of the sphere with coordinates -1, 6, and 4. A nonlinear equation in any two of the variables x, y, and z would represent a cylindrical surface. Now, the surface can be graphed by sketching the planar graph represented by the given equation on the plane defined by the variables present in that equation. So, when you have drawn the planar graph, what you do is you translate that graph parallel to the axis of the missing variable. So to illustrate, let us work on the cylindrical surface defined by the equation x squared plus y squared is equal to 4. Now, if you recall from analytic geometry, x squared plus y squared equal to 4 would just give us a circle on the xy plane. So what you do first is draw the circle x squared plus y squared equal to 4 on the xy plane. So that is what we have here. The center is at the origin, the radius is 2. So the intersection of the circle with the coordinate axis, x-axis and y-axis would be as indicated. You have 2, 0, 0, 0, 2, 0, negative 2, 0, 0, and 0, negative 2, 0. So having drawn the circle, what you do is you move it or translate it parallel to the z-axis because the z variable is the missing variable of this equation. So when you move the circle up, down, it will be sweeping some sphere or some space. That space is what we call the cylindrical surface. And specifically, it is called circular cylindrical surface because this equation represents a circle. Another example is the cylindrical surface defined by 4x squared plus y squared is equal to 4. Again, recall from analytic geometry, the graph as given by the equation in the xy plane would be an ellipse. And for the ellipse, its major axis is along the y-axis, the minor axis is along x. Okay, so if we are going to sketch the ellipse, its center is at the origin, major axis along y, semi-major axis is of length 2, minor axis is along x, semi-minor axis is of length 1. So the ellipse there will have ends of major axis at 0 to 0 and 0 negative to 0, where the ends of the minor axis are at 1, 0, 0 and negative 1, 0, 0. So when you have drawn that ellipse, what you do next again would be to translate it parallel to the z-axis, the axis of the missing variable. Okay, now, since this equation here represents an ellipse, then the surface generated is what we call an elliptical cylindrical surface. Okay, here is another example. Working with the equation x squared is equal to y. Again, let us sketch the surface defined by this. The equation represents a parabola on the xy plane. So let us draw that first. And this parabola x squared equal to y will have vertex at the origin. So there. And that the axis of symmetry is the y-axis. And the parabola opens to the positive direction of y. So the parabola given by the equation is this curve that I'm tracing there. And then what you do is again translate it to the direction parallel to the z-axis. So again, you move this parabola up and down and you'll be able to sweep that particular surface called a parabolic cylindrical surface. So remember, if you are given a nonlinear equation in any two of x, y, and z, then the surface defined is a cylindrical surface. To sketch the surface, what you do is to draw first the curve, the plane curve as defined by the given equation, and then after that, you translate it parallel to the coordinate axis of the missing variable.